I think here we find the power of good enough. In engineering, we of course try to always stress the need for optimality and perfection, which is very good. But if you look at biological systems, good enough gets you a very long way. And so what we're doing is we're able to create systems that are bio-inspired to try to take advantage of the solutions that we see in nature. We don't do this in simulation and then apply it to the robot. We give it limited experience in the physical world, and in so doing it learns to do something relatively well and very quickly. And so what we see is that through limited experience you can get to good enough solutions that may not be optimal, they may not be the most efficient, but they're certainly useful.
Most roboticists will teach their robots how to do a particular task and how to be good at it. But we are here trying to teach our robots how to learn. So our system will first start with a random set of movements to figure out how to control its body. It's very similar to what babies do when they're, doing what we call motor babbling. They try to pull different muscles and figure out how to control their limbs. It's very similar to that. And after that, we ask it to propel a treadmill. In our case, the reward was how far you can propel the treadmill. So the farthest the locomotion pattern can propel the treadmill, the more reward you will receive. Well, our system is bio-inspired at two levels. First, it is tendon-driven, and that gives us so much versatility and agility.
So we built a leg with that specific tendon routing that we know that we'll be able to move in this way. It doesn't know how. It has no idea, but it is physically capable of doing it. That's why it's so important to design the tendon routing super carefully.
And the second part is the learning and control algorithm is inspired from the way that the nervous system works.
These robots, in the same way, they develop habits that are essentially a product of their experience, and so they have a little bit of a personality.
This system starts with zero experience and zero self-awareness. Over every individual experience, it has the opportunity to take that experience and incorporate that into its self-identity.
They can generalize. They can then do something that is slightly different from what it did before, and then they can expand their repertoire like that. And so what we're trying to do is we're trying to look at the problems of how to build better robots from a perspective that considers the biology, the mathematics, the engineering, the computer science.